In this video, we're going to look at what we mean by a logarithm and what is a logarithm. I'm just going to mention some prerequisites. Before we talk about logarithms, you need to know about indices. For example, what does 2 to the power 2 mean? 4 to the power 0.5, or in other words, 4 to the power of a half, or 10 to the minus 1. If you're not comfortable with these, then you need to stop and revise these. And you also need to know about functions in the form y equals a to the power of x. In this case, we have y equals 2 to the power of x, y equals 5 to the power of x. And this is something you may have come across, y equals e to the power of x. Nothing special about this. This is just an irrational number. So instead of writing it out, we give it its own special symbol. So I could have easily written y equals 2.7 to the power of x. And you need to understand about these types of functions. If I was to plot them, what would they look like? I'm just going to very quickly, if I had a pair axes there, they would all look like this. The notable thing here is as we go to minus infinity, they approach the x-axis. They all cross the y-axis at 1, because it doesn't matter what the base is. When we raise a base to a power 0, then the value will always be 1, and they will rapidly increase. So you need to be comfortable with that. Here we have a logarithm, and what I'm going to show you now is how you must think about this logarithm. What is the index to the base 2 that results in 8? And this is the way you should always, in your mind, read a logarithm. At least that's my suggestion. And if I was to write that in equivalent algebra that you are familiar with, what is the index? So all right, I'm unusually going to put a question mark here. To the base 2, that results in 8. And now this is a form that you are much more comfortable with and can understand. So I would always convert between this, which can be difficult to see what's going on, to this, easy to see what's going on. Here's another example. I'm going to do exactly as I suggest. Do this every time. Read it as a sentence. What is the index? To the base 3, that results in 81. So I know this isn't mathematically correct to put question marks, but there we have. What is the index? To the base 3, that results in 81. And so again, here we have a mathematical equation that you can solve, and hopefully solve in your head actually. 3 squared would give me 9, 3 cubed would give me 27, and 3 to the power 4 would actually give me the 81 that I'm seeking. So I could say equivalently, the answer to that is 4. But it's important that you write this down like this. One that's a little trickier, but the method exactly the same. What is the index? To the base 2, that results in 4. So what is the index? To the base 2, that results in 4. And again, this is where I've mentioned your prerequisite with indices needs to be good, because actually I can see the index here is going to be a half, because I'm going to be taking the, no it isn't, it's going to it's going to be 2. Right, in my own mind I'd set this up as a slightly different problem, so I'm going to write the problem that I'd intended this to be. Right, that's the problem I intended this to be in my mind. And so we're going to evaluate this. What is the index to the base 4, that results in 2. And now it's true for me to say, if your knowledge of indices is good, you'll recognize that this we're taking a root of 4, so the answer would be 4 to the half. You must be comfortable, entirely comfortable, with the equivalence between this logarithm and what you're more used to. These two equations are exactly the same. And this is saying, what is the index to the base 2 that results in 16? So I would start off in my own mind writing it like this. What is the index to the base 2 that results in 16? And it's telling me, well, it's 4. So it's actually told me, you know, the answer. I've not had to do any working out here. But the point I'm making is this and this are exactly the same. And really, for you to progress with algorithms, you must be 100%, on solid rock foundations in being able to move between these two interpretations fluently, easily, without any trouble at all, between one and the other, backwards and forwards. I'm going to just have a look at some example questions now. Rewrite as a logarithm. So now we're going to go back the other way. We're not solving any equations here. There's not an unknown. We're just writing it out in a different way. So you've got to think, I'm asking, what is the index to the base 4 that results in 256? And I can see what the answer is. It's 4. So again, your brain's having to work a little bit in reverse. So make sure you're comfortable with this. It's easier sometimes, to go from here back, because what is the index to the base 4 that results in 256? And I'm not working anything out because it tells me, well, that base is 4. So you may find it's easier to work this way. But of course, in exams, you're going to be tested on things that aren't so comfortable. So you've got to, gain the skill, the fluency to easily move that way. A slightly different problem, rewrite using a power. Log 2 to the 25 equals 2. So what we're saying now is this is where we're going the other way, and hopefully this is the way that you find easier. What is the index to the base 2 that results in 25? And it's actually told us without us having to do any working out. So we've got to pretend, we're and of course this is wrong. So I'll rewrite this question as I intended it to be. What am I doing? So this is the question that I'd intended to rewrite it as a power. So what is the index to the base 5 that results in 25? And actually it gives me the answer. It's telling me that the answer is to the power of 2. Okay, so just to be clear, that doesn't make sense. Find the value of, so in this case we're being asked to evaluate it. So what is the index to the base 2 that results in 8. Now these simple type questions here are just getting you used to what we mean by a logarithm. Um, so you're going to do these in your head, and if necessary by trial and improvement. Certainly not going to be 2 to the 1. 2 to the 2 is 4, and I can see then actually that it's going to be 2 cubed is equal to 8. So the value of this is 3. You can of course do this on the calculator, but don't, because these early exercises are all getting understanding. Again, another problem asked in a slightly different way, but again I'm going to start it off in exactly the same way. You'll notice that all of these exercises I've always started off in the same way, and then solved it as necessary. So what is the index to the base 5 that results in the value x? And it's telling me that the answer of that index is 4. So now it's told me and so I can just evaluate this. 5 to the power 4. So again, I know I'm sort of laying it on, but the point is I've never attempted to solve this before I've written it out in this format that I'm used to. So the way I always approach it is never try and just solve it from this point. Always write it out in the way that is more familiar to you. Just to end, I'm just going to show you a few things. This is saying, what is the index to the base 2 that results in 2? So what is the index to the base 2 that results in 2? And we can see here, well, it's got to be to the power of 1 using your knowledge of indices. The same here and the same here. And what you'll find is, when you're trying to find using a base, that number which is the same as the base, it's always going to be to the power of 1. And you'll soon recognize this. So, what is the index to the base 16 that results in 16, and it's going to equal 1. So you'll quickly come to recognize these special cases, and you'll just know that they're always going to be equal to 1. Here we have, what is the index to the base 2 that results in the value of 1? And again, it's using your knowledge of indices to know that any base to the power of 0 is always going to be 1. So similarly, what is the index to the base 8 that results in the value of 1? And again, I know it must always be an index of 0 to give me the value of 1. So again, you do enough of these, you'll come to recognize this particular situation. Doesn't matter what the base is, but when you're seeking the value to be equal to 1, the index is always going to be 0. The last thing I'm going to mention is you're going to come across something like this, and it hasn't told me what the base is. It's saying, what is the index? And it hasn't told me what the base is. That is equal to 100. And it's just simply that. In the absence of any explicit information, take it to be the base 10. The reason is simple, that the base 10 is so important that we actually don't even bother mentioning it when we write log. We just assume it's to the base 10. And so in this case, we could see that's a value of 2. I'm going to give you some suggested exercises. Don't use the calculator. Well, when you're doing these, this is all about getting an understanding. So do not use a calculator. These you could evaluate these easily using the calculator, especially a modern calculator with different bases, but don't.